This is page 3 of your review. Triangle QRS and triangle QTV are similar. And so I take this statement right here and I just write it 4 different times because I have 4 different choices. So TV is to RS as TQ is to RQ. I like that one. VQ is to SQ as RQ. VQ is to SQ. I started here, and then RQ, I can't start there. Okay, this is not new over old. This is not new over old equals new over old. Because if I do VQ, that's here. SQ is here. RQ is back to here. So that's not in the right order. Okay, TQ. TQ is to VQ as TV is to TR. TR isn't even a segment. TR is not even, this right here is a partial piece of a triangle. So that doesn't work. TV is to VQ as RS is to RQ. Notice that VQ is first and last and RQ is first and second, so that doesn't work, so that's this one. I never look at the picture. I only look at, well, I did look at the picture because of the partial. But I knew that it wasn't there because TR didn't show up in any of these. So put your similarity statement one on top of each other and underline them and make sure that you underline them in the correct order. Okay, Janelle drew KL in isosceles trapezoid to create a similar trapezoid. So it tells you there's a trapezoid in an isosceles to create. Okay, so we have F, K, L, J. So we do have a isosceles trapezoid here. And we have a F, G, where did I? F, there's the F, G, H, sorry, K, G, H, L. So there's a small one here to create similar trapezoids. Okay, so here we go. Based on the given information, what are the values of Y and W in centimeters? So Y and W. So 3 is to 9. I will pause right there. Okay, I had to pause because I was mind blanking. But 3 short is to long, as short as to long. So that's 9 is to W. So then that is 9 times 9 equals 3W. 81 equals 3W. W equals 27. So this is 27. Isosceles trapezoid, the reason that word is important is because that says 5 and that is 5. And then whatever number this is, these are both Y's. So I then have 5 is to Y as 3 is to 9. Multiply by 3, multiply by 3, Y equals 15. Fill in the blank. If two figures are similar, then their corresponding sides are proportional in similar figures. If two figures are similar, then their corresponding angles are congruent. Because remember, same shape, same angles, different size is the definition of proportional and similar, or similar figures, and this different size means that they are proportional. What scale factor would you produce a copy? K equals 1 is copy. Enlargement, the scale factor is larger than 1 for an enlargement, and the scale factor is less than 1 for a reduction. And they are from 0 to 1 is your scale factor, because remember we had a problem that had a negative scale factor and all that did was flip the figure. Figure on a coordinated plane is dilated. So we know dilated, and every time we see the word dilated, we're going to think multiply. Point A39 is dilated, so 3, 9 goes to 1, 3. And this is A. Oop, that's A, not A prime. That's A. Becomes A prime. And remember, we're multiplying. Bobby says that the scale factor was 1/3, so 1/3. Do I multiply here to get here, and do I multiply here to get here? Yes. Betty says it was a factor of 3. Because we're going to the prime, Bobby is correct. What is the equation of the graph shown? Does the graph represent a proportional relationship? So we have two things to do, one here and two here. Equation of the graph. I have a y-intercept of 3 and a slope of 3 down and 2 right. So y equals -3 halves x plus 3. Does the graph represent a proportional? This is not proportional. Oh, 3 questions. Why or why not? Does not pass through origin. That's page 3. I'll do another video for page 4.